the probability that a randomly chosen male has a circulation problem is 0.25. I use C for the circulation problem event. So then probability of C equal 0.25. Males who have a circulation problem are twice as likely to be smokers as those who do not have a circulation problem. Okay, here we need to understand few things. First, I will go with this smokers as those who do not have a circulation problem. Okay, I use S for the smokers. So then smokers as those who do not have a circulation problem. So what is the meaning of that? Yes, we already know these smokers are coming from the group who do not have a circulation problem. Understand? Then it is a conditional probability. Again, we know these smokers are coming from the group who do not have a circulation problem. Then C is the circulation problem. Then we know that is the conditional probability. Therefore, do not have a circulation problem should be C complement. Now, smokers. Right. Probability of smokers as those who do not have circulation problem. I use this probability as X because we don't know that. Now go back to the sentence. Male who have a circulation problem are twice as likely to be smokers as those who do not have a circulation problem. Males who have a circulation problem. Think about that. What is that? That is also a condition, right? Because we know males who have a circulation problem. Therefore, we know the male who have a circulation problem are twice as likely to be smokers. Therefore, this should be S. Then that equal twice of this one. Therefore, we can say 2 times X, right? So those two are the conditional probabilities. Then question is, what is the conditional probability that a male has circulation problem? Okay, they are asking conditional probability that male has a circulation problem given that he is a smoker. So they are asking this. Then how do we find this? Yes, first we know we can find probability C and S divided by probability of S. This is the conditional probability, right? Probability of C given S equal this. Then probability of C given S, we don't have that information, but we know the conditional probabilities here. So let me write down this probability of S given C equal probability of C given S divided by probability of C. Using this, we can write probability of C and S equal probability of C times probability of S given C. So plug this into this. So then we can write probability of C times probability of S given C. This one divided by probability of S. Alright, how do we find the probability of S? You know there are two groups. So let me draw this. You know the partition. So this the male group, and there are two groups, men who have circulation problem and who don't have circulation problem, right? So I write down this way. So this is the circulation and this is C complement. That is the only two group. But we have smokers of both group. So that is S. So this is smokers. Then how do we find the smokers? So we need to find the probability of C and S, this group, plus probability of C complement and S. You see that, right? So that is the probability of S, total probability. Therefore, I will write it down, probability C and S plus probability C complement and S. But we don't have an information. Therefore, we can write an information as we write over here, probability S given C. So using the same theory, we can write here probability C and S. We can say C time probability S given C plus probability C complement time probability S given C complement. Now we know all the information. Probability of C is 0.25. Probability of S given C is 2x divided by probability of C again 0.25 and 2x plus this one should be probability of 7. C complement should be 7.5 because from here probability of C equal 0.25. Probability of C complement equal 1 minus probability of C. Therefore, that is 0.75. And probability of C complement is 0.75 and probability of S given C complement is x. Now you see here this x, this and this are cancelled out. So then we can have the answer, it is 2/5. So that is the probability of C given S. Next one, how many ways are there to seat 10 people consisting of 5 couples in a row of seats if all couples are to get adjacent seat? Okay, let me explain this in easy way, I think. Well, there are several ways we can do this problem, solve this one and find the answer. But let me explain this way. Suppose there are 10 sheets, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now think about this way. There are 5 couples, right? 5 couples. So then I write this way: A B couple, C D couple, E F G H I J. These are couples, right? Now there are 10 sheets. Now consider this AB couple. So AB couple, if they are going to sit of this seat, how many possible ways he can do it? Yes, AB you can see, AB they can use these 2 sheets, right? And then O, we can say O, can they use these 2 sheets? No. Why? If they use these 2 sheets, then actually here one left. So then these conditions, we cannot satisfy this condition, right? What condition? The couples sit together, right? Therefore, that is not the one. If they pick this one, they can pick this one, or they can pick this one, or they can pick these two, and these two, and these two. So how many? Yes, only 5 ways, right? 1, 2, 3, 4, 5. Okay. You think that is the only way they can sit? No, actually. Because you see, first A, then B, but this one, BA. That is also choice, right? As choice. And BA, 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 BA. You see that? Now, how many ways? Yes, there are 8 possible ways. Sorry, 10 possible ways. But this here you see first one, second one, third one, fourth one, fifth one. Similarly, 6, 7, 8, 9, 10. Therefore, for the first couple, there are 10 ways they can sit, right? Suppose now they pick this one, A, B or B, A. It doesn't matter for the first two sheets, right? Now, for the second couple, okay, then we consider CD. Okay, how many ways for the CD? This couple. Yes, they have to pick this one, not first two because they have already booked it, right? So CD, this one, this one, this one. Or similarly, DC, 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 DC. So how many ways? 1, 2, 3, 4. Similarly, 5, 6, 7, 8. Yes. Second one is we can say 8. So then actually you can apply m time n rule for these two only, then 10 times 8, right? 10 times 8. Then I use these two, CD. Then how about the rest? Now I think you understand how it works. So then for the rest, EF, for this couple, EF, they have 1, 2, 3 and 6 ways, right? They have 6 ways. So multiply by 6. So then think you got these two EF, right? So then we can use the next GH. So GH should be this way. So it is how many ways? This one, or sorry, before I fill this, they have how many ways? 4 ways, right? Because GH, let me use this color, GH, GH, or HG, HG. So they have 4 different ways to choose the sheet. Therefore, it is 4. Now, similarly, the last couple, they have only 2 different ways, right? So then, actually, this is what is this one? This is the MN rule, the extension of the MN rule. Then 3840. So that is the answer for this problem. Next one, 12 politicians, of which 6 are Democrats and 14 are Republicans, are having a tea party. To prepare, they need to choose 3 people to set the table, 2 people to boil the water, and 6 people to make the scones. Each person can only do one task, and people who are not assigned tasks do not help. In how many different ways can they choose which people perform these tasks? Yes. So how many politicians there are total is 20. So 20 they are going to assign 3 jobs. Here 3 people to set the table. Okay. So how many different ways we can find 3 people? Yes, we have 20 politicians and 3. Therefore, for that case, 20 C 3, right? It means 20 choose 3. Understand that? Yes, because here we don't use P. Why? Because suppose A, B, C, there are 3 politicians. So we can pick this one first, A, and B next, and C next. Okay, this is the ABC group then. ABC, and also how about they pick first B and then A, then C is still ABC, right? Yeah, you understand that part. Therefore, we use here 20 choose 3. Once you pick 3 for the first job to the set the table, then how many we have? We have 17, right? Then 17 we need to, from the 17 we need 2 people to boil the water. Therefore 17 C 2. Right. Now how many we have? We have only 15 people, 15 politicians. Now how many people we need for the next one? 6 people. Therefore 6. Now you see the how many different way we can pick for each job. Then you can apply MN rule. So multiply this. So this is the answer for the part A. Part B. Suppose that Democrats all hate tea. If they only give tea to 10 of the 20 people, what is the probability that they only give tea to Republicans? Alright. First, they're asking probability, right? First, without any condition, we find the different ways they give the tea. Okay, how many teas they are going to give? 10. Therefore, how many people we have total? 20, right? So let me write down total ways to give tea to 10 people, right? 10 people. Yes, you know we have 20 and choose 10. That is the different ways to pick 10 people for the tea without any conditions. But this mention, if they only give tea to 10 of the 20 people and Democrat all hate tea, right? So let me write this number of ways for tea to be given to Republican. Because they only give tea to Republican, right? Probability that they only give tea to Republican. So that is the question they're asking. What is the probability that they only give tea to Republican? Right. Now, how many Republican over there? Actually, Republicans, we know the previous, go to the problem. Republican, 14 Republicans. You see that, 14 Republicans. Therefore, we have only 14 Republicans and we choose 10. So that is the number of ways for T to be given to Republican. Therefore, we can find the probability only for the T, give T to Republican. I say probability of R Republicans, right? Then that is this 14C10 divided by total 20C10. So you can simplify this. So you know what is the 14C10. You know how to do it. Factorial 14, factorial 10 and 14 minus 10 factorial, which is 4 factorial. And similarly, you can find the 20C10. So factorial 20, factorial 10, factorial 10 again, because 20 C 10, right? Yes. So you can simplify this. Okay. So multiply, plug into here. So you can simplify, but you can have factorial 4 and factorial 10 and divided by factorial 4 and 20 factorial. So you can write without factorial here. So 14 actually 4, 5, 6, 7, 8, 9, 10. So factorial 4 is cancelled. Then 14 cancel, therefore 15, 16, 17, 18, 19, 20. So you can multiply and get the answer. So the last one, if the Democrats only give tea to 10 of the 20 people, what is the probability that they give tea to 9 Republicans and 1 Democrat? Right. Again, now we know they're asking probability. Now we know without any condition, there are 20, 10 different ways, right? Right. Now, number of ways, how do we pick? They pick probability that 9 for the Republican. So, how many Republicans they have? Yeah, let me write down. Number of ways to give tea to Republicans and 9 Republican and 1 Democrat, right? Democrats. So this equal, okay, 9 Republican. How many Republican? There are 14 Republican. We choose only 9 and multiply. How many Democrat? 6 Democrat. We choose only 1. So that is the number of ways to give tea to 9 Republican and 1 Democrat. Then what is the probability of that? So I use the probability of the above event, right? I say number of ways to give the tea, 9 Republican and 1 Democrat. This equal, you see 14 C9 multiplied by 6 C1 divided by 20 C10. So that is the answer for this. Next one, how many different arrangements of the word PARRAMATTA are possible? Yes, think about this. How many P's we have? P we have just one. And how many A's? A 1, 2, 3 and 4. We have 4 A's. So 4 A's. And R 1, 2, just 2, right? 2. And we got P and M 1 and T 2, right? Then 4, 5, 6, 7, 8, 9, 10. 10 letters, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Now, how many different arrangement of the word, right? Yes, the word are possible, right? So let me give you an example. If suppose we use same P, I use there are 4 A's, so I use A1 and R as an example, okay? A2, M, A, T, T, A4, right? So then next time I use P, A2, R, A1, M, A4, T, A3. So do you see any changes of this word? No, right? Even you change the A position, it's not different. Why? Because A is the same, right? There are 4 A's. Therefore, how do we find the number of different arrangement of this? We know total it is 10 if we had the different letters, but we have similar letters. Therefore, we divide up by 4 because this is 4 here because we don't divide this one factorial 1 and it is a factorial 1. So then divide up by factorial 2 and again divide up by factorial 2. So that is the different arrangement of this word. Next, how many arrangements of the letters of the word remand are possible if there are no restrictions? Okay, if there are no restrictions, you see we have one from each word, right? Therefore, what are the number of ways? We can say factorial 6, right? Because 6 letters, 1, 2, 3, 4, 5, 6, and different letters, no, the same letters, therefore factorial 6. Or you can say this is actually same thing, 6p6, right? 6p6. So that is the same. So factorial 6. Then they do not begin with RE. Okay. Now first think about this way. Without any condition, how many different arrangements? We have 6 arrangements. But they are asking they do not begin with RE. Right. If they do not begin with RE, you see, let me do this way. RE, this as a one group, right? Then MAND. Okay. They do not begin with RE. Suppose they begin with RE. So RE here fixed. Okay. RE here fixed. So it doesn't change. Okay. Now, how many different ways we can arrange these 4 letters? Again, think about RE is RE. Both letters are at the beginning. Now we need to change these 4 letters. How many ways we have? It is 4 different ways. That is the only case we should subtract. But actually understand that, because if you think, how about ER? Yeah, it is okay. ER is okay because it say only RE. Yeah, you can consider ER, MAND. Yes, you can consider this. This can be counted, right? But only thing is this one. So this, if you start thinking RE is at the beginning already, this one, it is fixed. So we have 4 letters. How many ways we can arrange this? As an example like this. So factorial 4. Therefore, we can subtract factorial 4 from the total without condition. So then you see it is factorial 6 minus factorial 4. But if this asks RE and ER, then you have to consider both ways. Okay. Right. Next one. They have REM together in any order. Okay, actually that is the one I explained like ER, okay, but REM any order, right? Now how do we do this? Now suppose you have and they have REM together in any order, right? REM, okay, AND as an example, or you can have this ERM AND, or you can have MERAND. However, you can go further, but another example I can say AREM AND, this REM together. So you can change this one and keep in same thing here. You can change the order of REM and keep in the rest of the same. Similarly, you can think this further, right? So then tell me, if we keep REM together, like again, let me write down this one. So I say REM together, then what are the rest of the letters? A and D. Now we consider REM as a one letter. If you consider REM as a one letter, how many letters we have? 1, 2, 3, 4 letters, right? Therefore, how many arrangement we can do here? Then 4 factorial 4. But you know, REM can be arranged in any order. Therefore, how many ways we can change this REM? Because in this circle, we have 3 letters. So you can pick REM, RME, MER, like that you can change the order. How many letters you have? 3. Therefore, we can have 3 different ways. So you can use the MN rule again 4 times 3, 4 factorial times 3 factorial. So that is the total different ways we can arrange this with this condition. Okay, REM together in any order. Next one, assume A and B are independent events. Okay, if A and B are independent, so you should get this probability A and B, we can write probability of A times probability of B. Or we can write A given B equal probability of A, or probability of B given A equal probability of B. So you can use any of these three. Okay, keep in mind that we know probability of A is given, probability of B is given. Let C be the event that neither. Okay, if C is neither A nor B, then we can say C event equal A union B is either. So neither A nor B occurs, then complement of that. And D be the event that exactly one of A or B occurs. Okay, I will leave that for a few minutes. So let me explain. Find PC. Okay, how do we find the PC? Probability of C. So this is, according to this part, probability of A union B complement, right? So we have complement, so you can write 1 minus probability A union B. Then we know 1 minus what is the probability of A union B. You know this is 1 probability of A plus probability of B minus probability of A intersection B, this. But we don't have probability of A intersection B. But we know A and B are independent. Therefore, according to this one, as I explained before, we can write probability of A and B equal probability of A times probability of B. So now we know all the numbers or probabilities. So we can write 1 minus 0.2 plus 0.3 minus 0.2 times 0.3. So this is 0.56. So that is the probability of C. Next one, find the probability of D. Okay, what is the D? D be the event that exactly one of A or B occurs. Okay, one of A or B occurs. If you cannot write B, just draw a Venn diagram. Okay, this is A, this is B, right? So exactly one of A and B, right? Exactly one of A or B, right? So let me explain this. So exactly one of A or B means this one, that is the exactly A, only A, and this is the only B. Therefore, these two are the two areas we should need for the D, right? Right. So how do we write this one? It is easy to write. You consider the first A union B. If you consider A union B, then you will get this part also. It means two red color areas and this part, joint part, right? But we don't need that part. Therefore, that is, what is that? That is intersection. Therefore, we can subtract A intersection B like this. You see that? A union B minus A intersection B is the D. What is the D? D be the event that exactly one of A or B occurs. Now they are asking probability of D. Probability of D equal probability of A union B minus A intersection B. So this one, right? Probability of A union B minus A intersection B. That is the probability. So then how do we do this? You can write probability of A union B minus probability of A intersection B. Okay. Then probability of A union B can be written probability of A plus probability of B minus probability of A intersection B. That is for the probability of A union B. But you see, we have this here also, probability of A intersection B, and here also negative, right? Negative sign. Therefore, we can make this 2 times that. Then probability of A plus probability of B minus 2 times probability of A times probability of B. Now you can plug the number probability of A 0.2, probability of B 0.3 minus 2 times probability of A times probability of B. The answer is 0.38. Next one is asking probability of A given D. So that is the conditional probabilities. Then you know A and D divided by probability of D, right? So this is, you know, probability of A and D. We don't know probability of A and D, but we can find A and D. How do we find the A and D? Okay, again think about this. You know this is A. Let me draw this, okay? And this is B. So A and D, you know A is this area, A is that. So then D, according to this explanation, red color area, you see this. Therefore, I will do the this here, this area and this area, that is the D, okay? That is the D. So then we need intersection, therefore the area with both colors, right? Which is this area, right? This is the area we need. So how do we get that area? We can write probability A intersection D, we can write probability of A. So that is the whole thing, and A, right? This A whole thing, this one, and we subtract probability of A intersection B. So then we can have probability of A intersection D divided by probability of D. So then we know all the information. This is 0.2 minus 0.06, right? Because why? How do we get the probability of 06? Probability of A intersection B equal probability of A times probability of B. So you know this is 0.2 times this is 0.3. So then divided by probability of D, we know that 0.38. Therefore, answer is 719. Are C and D independent? Justify your answer. Okay, C and D independent. There are several ways you can do it. But here, if C and D independent, we can use this. Probability A, sorry, it is C and D independent, right? Yes. Then we can use this. Probability C and D that equal probability of C times probability of D. We need to check this one. We know already probability of C and we know already probability of D. So therefore we can find the C and probability of C and D. Let me find probability of C times probability of D. Probability of C equal 0.56 and probability of D equal 0.38. So this equal 0.56 multiplied by 0.38, that is 0.2128. Right. Next, we need to find the probability of C and D. So what is the C? C be the event that neither A nor B occur, right? So if you don't understand that, let me explain using this. Here, this is A and this is B. So C is the event that neither A nor B occur. It means that this is the C. You understand? This is the C. That is the C, okay? That is C. Then what is the D? D is the event that exactly one, right? One occur, you know, this and this. So do you see any what we call intersection of this? Because we need and. No, right? No any intersection, no any area that are colored with both colors, right? No. Therefore, probability of this equals 0. But this is not equal 0. That is 2, 1, 2, 8. These two are not equal, right? Therefore, C and D are not independent.